today, you're going to need some yarn, you need a rubber band, and so the first thing we're going to do is pull rubber band that has flexibility because it's rubber. Now we're going to try yarn. It has, hold on to it. It has no, doesn't stretch. So that is the same experiment for today.
Alright, so we're going to need a bowl. We're going to need to pour some milk in that bowl. We're going to need food coloring. And we're going to need dishwashing liquid. So we're going to take our bowl with some milk in it. And we're going to pour some different colors in there. Spread. Do it all over. Do some yellow. Do some green. Do some blue. If I can get it out. Do some blue. And we're going to do some light green. We gotta have pink. Alright. So now that we have this, all different colors, we're going to pour some dishwashing liquid on it. Did you see that? That's cool. Boom. You see that? So cool. That's a pretty cool experiment. Alright, so we're going to need a clear bottle. We're going to need Alka-Seltzer tablets, cooking oil, and food coloring. And we're going to need a funnel. Need some water. And put it in our bottle. Then we're going to put some water. Pour some water in here. See what's that? Put that. Now we're going to take, so we're going to take our cooking oil. We're going to put some in there. The water's down here, cooking oil's down up there. Pour some more in. Alright, now we're going to take some food coloring. You can pick whatever color you want. I'm going to do blue, because I don't think green would turn up that well in the oil. And I'm going to put some drops in there. And they're going to all sink to the bottom. And they're going to all sink to the bottom. Almost at the bottom. Alright, so now we're going to take our Alka-Seltzer tablets. I'm going to put them in. I have to break them up. You can see all the dye, hopefully about to rise. Take a couple more. You can see it coming all up. Most of it is coming up. This is so cool. We're gonna put some more tablets in there. It's all rising. So we're gonna wait a couple minutes and see if it'll rise anymore. So it's been about 2 minutes. It's still rising. I'm gonna put a little bit more of the tablets. This is really cool. It's just gonna keep rising and rising and rising. Put a little bit more food coloring in and see what it does. So I'm gonna check it back in like 2 minutes. Alright, so it hasn't been 2 minutes, but I just put in a little bit more of the tablets and it's still rising. It's still going all about in there. And that foam on top, because these tablets are not just Alka-Seltzer, they are mint denture cleaners, which are Alka-Seltzer tablets. So I just put the last tablet in, and this is looking even cooler than before. And before it was looking pretty cool. So I put a little bit of duct tape on the top, so when I hold it up to the light, none of the light goes out of it. It just, like, you don't see any light going out of it, because the black cap, and this, the bottom, is somewhat black. It's really dark blue. Alright, for this experiment, we're going to need steel wool, vinegar, a thermometer, and some water, a pencil, and a sink. So we got a jar, and we're going to stick our thermometer down into the jar. We're going to let that sit for 5 minutes. So it's at 0. And we're going to wait 5 minutes, so I'll be back. Currently the temperature is at 69 degrees Fahrenheit, and we're just now at a minute. So let's see what it is in 5 minutes. Alright, so the time is at almost 5 minutes, and it's still says 69. It's about the temperature in the room, so it wouldn't surprise me if this is the same temperature. Now while we're doing that, while this is finishing up, we're going to take some steel wool and we're going to soak it in some vinegar, and then we're going to put it in the jar with the thermometer and see how the temperatures change. So I'm going to open this. That's why I'm wearing gloves, because this stuff can prick your fingers pretty good. So I'm going to get some of this stuff. So I'm going to get some of this. And we're going to put this out of the way. Take our bowl, set that in there. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. And we're going to put this in the jar. Now I'm going to get some vinegar. I'm going to pour this in here. Alright, so we got some vinegar. And we're going to pour this in here. Alright. There's some water in there. We'll soak this all up. It's another reason why I'm wearing gloves, because I do not want my hands to smell like vinegar. It's actually white vinegar. Oh, that smells nasty. Steel and vinegar do not mix. So that's all mixed. Set that aside just for a minute. Now we're gonna take our thermometer out. We're gonna lift our makeshift cap, and it dropped to 68. I'm gonna bring this out a little bit. I'm gonna put this, wrap this around it. Shoot. I'm gonna try to wrap this around it. See how that goes. Make it stretchy. It's not that stretchy. You know, I have to try to finger this through and see how that. Alright, so now we're going to let that sit for another 5 minutes, and then we're going to check the temperature. So, resetting it. It's started. So I'm going to check back in 5 minutes. Alright, so we are at 5 minutes and 12 seconds. And the temperature did rise to 73. So it must have been the way the steel wool was wrapped that it made it rise a little bit faster. Take this out. Now we're going to look at it. Look at that. All that brown is rust. Rust on the steel wool. It made it rust much faster with the vinegar in it, because vinegar is has a lot more acid than water. If we were to just put water on it, it would not rust that fast. When something rusts that fast, it's creating a chemical reaction, not changing the physical state of the object. And that is definitely a chemical reaction. Now, if we were just to put water in it, it would not be at that temperature. See, now it just dropped to 66 because it's out in the open. And all that moisture in the air, I don't know if you can see it, but it's all in the glass, and there's a bunch of moisture in there. And that is created by when something rusts, or especially at that rate, it creates moisture in the air. Because there's no air, there's not much air that's able to escape with the tinfoil on top. So that's a pretty cool experiment. Alright, for this experiment, we're going to need a tray, some styrofoam cups, and 1/4 cup of nail polish remover. So we've got our styrofoam cups, 4 of them stacked upside down on our tray. Now we're going to pour 1/4 cup of nail polish remover in to this, and then we're going to pour it on to our styrofoam cup. So I'm going to measure out 1/4 cup. Let's see if this is 1/4 cup. It's about a fourth of a cup. It's a little bit over, but this stuff is strong. It smells like pure alcohol. Now we're gonna pour a little bit onto here. And we're gonna see what happens. So, starting to get really soft. I'm gonna see if what else get it to do. Now it's starting to soak in. Foam. See how much it goes down? I'm gonna pour rest on it. It went through all of these cups. Pour some more. You can see it. It's eating through the whole thing. When I pick it up with some gloves on, it feels like something boiling underneath it. It's actually really cool because it's all eating down. It's all coming down. I'm gonna pour it back. The rest of this stuff, nail polish remover, back into here. So I'm gonna zoom out, and top of it, most of the other part of it, kind of like thick paper. I'm gonna pour some more. Or I'm gonna pour it this way. See what we'll do from there, because right now this is creating a styrofoam goop, like a sponge. That's exactly how I would describe it. Sponge. It's a goop. It's actually pretty cool. Make sure you wear gloves while you do this, because this will remove paint. So, basically creates a goop. The styrofoam will do a little bit more dramatic. It'll do a little bit more dramatic effect if you do have some from the beauty supply store, but this is just from Target, so it's not that strong. Now this is really cold on your hands, so it's actually really cool. So that's a cool experiment. You can do it at home. Alright, so for this experiment, we're going to need a mug, some milk in the mug, some hot cocoa, and a spoon, plus a microwave. So, first thing we're going to do is we're going to start putting some of our hot chocolate mix, about a tablespoon at a time, into our milk. I'm going to try 1 tablespoon, see how it does. Now you can see it's not mixing very well. All the powder is not mixing with the milk. Before we added the hot chocolate mix, the milk was a homogeneous mixture, meaning it did not have any other molecules in it. But now it's a heterogeneous mixture. Or at least it soon will. At least it soon will be, because it's almost mixed. Now you can speed up the process by putting this in the microwave, and that's how we would make hot chocolate. But because this is a hot chocolate mix, it does not go very well just making regular hot chocolate, or regular, it's just not go well, just making regular chocolate milk. See, the milk did not mix with the mix very well. And when we taste it, it just tastes like milk with a little bit of powdered hot chocolate on top of it. So I'm gonna go throw that in the microwave for about 30 seconds, and then I'll be right back. It's been 1 minute. It's been about 40 seconds. I had to put it in for an extra 10 seconds because it was just about lukewarm. Now, look at that. It mixes. Just turn off the light. Dim it a little bit. And you can see it's mostly mixed. And this is about warm. It's not hot. I would warm it up for another 40 seconds if I wanted to comfortably drink it. I'm gonna add another tablespoon and see how that mixes. And it mixes pretty well. There's some on top because it's starting to get colder because I'm mixing it. So I'm gonna go throw it in for another about 40 seconds, and then we'll see what happens then. Alright, so that was the 40 seconds. So it's been another 40 seconds in the microwave, and I'm gonna mix it up. It's all mixed together. Now let's see how hot it is. That's comfortable drinking for me. Now, let's see what happens when I had a half of one. I'm not going to add a full one because it's already pretty sweet. So it's about half a tablespoon. Put it in there. And mix it up. And it mixed. So when it's warmer, it mixes better. When it's colder, milk stays separate from the mix. Experiment. Alright, so that's a pretty cool experiment. Make sure you check out this book for where I get all my experiments from. It's called Exploring Creation with Chemistry and Physics from Young Learners series by Jeannie Fulbright. Very cool book if you want to know some cool facts about science and get some really cool experiments.